Hello, grade 9. This is the last lesson in our geometry curriculum, the seventh lesson in the fifth unit. Its name is angle of tangency. Okay, what's angle of tangency? This is the angle which is composed of the union of two. We know that any angle, it is two rays and a vertex. Okay, so it is composed by two rays. One is the tangent of the circle, and the other contains a chord of the circle. This angle is the angle between the tangent and a chord, but this chord, it must pass it through the point of tangency. Okay, not any chord, not this chord, for example, and this tangent. No, it must pass through the point of tangency. Okay, so in the opposite figure, as we see here, AC is a tangent to circle A, and AB contains the chord AB. So angle BAC is the angle of tangency in circle M. Okay, and AB is called the chord of tangency of the angle. Okay, what will be the measure of the angle of tangency? By the way, I have different things, and all they are very logic. First, think that this angle of tangency equal half the measure of the arc intercepted by its sides. As you see here, its sides are BA and AC. These are the sides of the tangency angle, this one. Where is the arc intercepted by its side, between its side? This is the arc. The angle of tangency equal half the measure of this arc. If this arc is 120, so the angle of tangency is 60. If it is 140, the angle of tangency is 70, and so on. What about, I have here another angle of tangency. This is a chord ending with the point of tangency and D. So BAD is another angle of tangency. It's equal to what? It's equal half what? Half the arc which is intercepts by its side, the major arc BA. Okay, so equal half the AB major. Okay, let's see this drill. This is a quick drill. As you see here, AB, the major arc AB 230, so the minor one will be 360 minus 230 equal 130. So what will be the measure of angle ABC? This is that angle of tangency. It is equal half the measure of the arc is intercepted by its side, so it will be equal 65. This one passing through the center, and this is tangent, so this is 90 degree. It's also, if you follow this rule, you will find that it is half the arc intercepted by its sides, so this is 180, its half is 90. This one is equilateral triangle, so each angle equal 60. I want angle ABC. It is equal to what? ABC? Yes, it is always also equal to 60 degrees. Why it is equal to 60? Okay, why? As you see here, it is equal to the measure, have the measure of this arc, right? But I don't have the measure of this arc. You remember the rule that says the inscribed angle subtended by the arc equal half its measure. So if this one 60, so the arc will be 120. So the angle of tangency will be half this arc equal 60 degrees. Okay, what is theorem 5? And this is the last theorem we have. The measure of the angle of tangency, this is another measure, equals to the measure of the inscribed angle subtended by the same arc. Do you see this? You have just made it, just one. As you see here, the angle of tangency, we got it 60. From something we studied before, that this arc equal double the inscribed angle. So when you want to get the angle of tangency, it is half the arc. Okay? This is a theorem. The measure of the angle of tangency equal to the measure of the inscribed angle subtended by the same arc. This is the arc which is between the two sides of the angle of tangency. So where is the inscribed angle subtended by it? This is the inscribed angle. So the angle of tangency equal exactly the inscribed angle subtended by the same arc. As a corollary for this one, the measure of the angle, do you remember the relation between the inscribed angle and the central angle? Who can remember? Excellent. The inscribed angle equal half the central angle subtended by the same arc. We have just said that the angle of tangency equal the inscribed angle subtended by the same arc. So the angle of tangency will be half the central angle subtended by the same arc. If you have BAC, here's the angle of tangency equal half AB arc, and at the same time AB arc, measure of AB arc equal the central angle. So the angle of tangency equal the central angle subtended by the same arc. A very important remark here, that the angle of tangency is supplementary to the drawn inscribed angle on the chord of the angle of tangency. Okay, this is the chord of tangency, and this is the inscribed angle on the chord, the inscribed angle of the chord. Okay, so the angle, this angle, the inscribed angle of the chord, and on one side of it, okay, and the angle of tangency are supplementary. Okay, why they are supplementary? Because here if BD is a tangent to circle M, and ABD, as we know that ABD, where's ABD? ABD, this angle equal what? Angle ABD equal half arc AEB, right? Or the minor arc AB. And at the same time, AEB, we said it is equal to what? AEB, it is equal to the tangency angle. But here, I need that this angle AEB, it is equal half the arc subtended by it. This is the inscribed, okay? Inscribed AEB. It is equal to half this arc ACB. When I want to add the two things I have got, I will add angle ABD with angle AEB, ABD and angle AEB, these two angles. When I add them equal to what? Equal half the arc AEB plus half the arc ACB, AEB and ACB. As you see, they are completing a circle. So I will take half common factor, so AEB plus ACB is the whole circle, which is 360. Half 360 is 180. What is 180? This is the sum of the two angles. That's why they are supplementary. In each of the following figures, please find the value of the symbol used in measuring. If I want angle X, okay, let's revise first. I have the angle of tangency. It is equal half the arc that it is intercepted by its sides. It is also half the central angle subtended by the same arc, and it is equal to the inscribed angle subtended by the same arc. And also the angle of tangency is supplementary to the drawn inscribed angle of the chord of tangency. Okay? Okay. Here I want angle X. Angle X, it is ABC, it is an angle of tangency. It is equal to the half the arc intercepted by its sides, but I don't have this arc. But I know that ADC is inscribed angle, so I can get Y first. It will be equal 120. Then X will be half Y will be 60. Or from the beginning, I know that X, 140, and this is 70. Okay? Or I can get X the first. X equal exactly angle D, because X equal, or the angle of tangency equal the inscribed angle subtended by the same arc, so it will be equal 70, and AB will double it, it will be 140. This one, I have MAB 25. I want X, this angle, okay, and I want angle Y, okay. First, I have MA and MB are 2 radii, so this will be 225. This angle 180 minus 50, it will be 130. And then what will you get next? This is, as you see, this is inscribed angle. sorry, angle of tangency. Where is its sides? Its sides is A, B, and BC. Where is the arc between these two? It is arc AB. See, it is suspended by this angle. This is a central angle. The central angle equal this arc, and we said that the angle of tangency equal half the central angle because it is equal half the arc, and the arc and the angle, the central angle are equal. So x will be half 130. It will be 65. What about angle y? Angle y, this is an inscribed angle for which arc? ADB. This is inscribed angle. Where is the arc suspended by this one? Here is the arc AB. Can you get the measure of the arc? And this inscribed angle will be half of it. Yes, I know that the arc AB equal the same like the central angle, so this is 130. Then 360 minus 130, the major arc AB will be 230. Divided by 2 to get the inscribed angle, it will be 150. Okay, here he wants measure of angle ADC. ADC, this angle. Okay, first I have CAB. CAB, this angle of tangency, it is equal to this arc, half this arc. ADC, all of this one. I will not get benefit from it. But I can get this angle. It will be 80 because this is supplementary. This is also an angle of tangency. Okay? This angle of tangency equal what? It is equal to the inscribed angle subtended by the same arc. So angle D will be equal this angle of tangency. So angle ADC, it will be also equals 80. Here he wants angle BAD, this angle. Okay, what I have here? This angle equal half this arc. Do I have this arc? No. I have BC arc. Can you get AC arc? Yes. By what? This is inscribed angle for this arc. So the inscribed equal half the measure of the arc. So the arc will be 140. You can get BA arc by 360 minus the sum of 120 plus 140. It will give you 100. So the arc AB is 100. And I know the angle of tangency equal half the measure of the arc intercepted by its two sides. So it will be equal to 50 degrees. Example, ABC is a triangle inscribed in a circle. BD is a tangent to the circle. Okay. I have a given also XY parallel to BD, and I want to prove that XACY is a cyclic quadrilateral. Okay, first, what is the given? My very simple way. The given is ABC inscribed angle, BD is a tangent, so this is an angle of tangency. Who can remember equal to what? It is equal to the inscribed angle subtended by the same arc. This is the arc, right? اللي هي الانجل tangency have this arc. Where the inscribed angle for this arc? ACB. So angle ABD, this angle of tangency equal ACB, the inscribed angle. And also I have here what? I have here parallelism. What is the parallelism? XY parallel to BD and AB is the transversal. Then measure of angle ACY equal, where is the angle? Yes, BD and XY. So measure of angle what? Yes, letter Z. Here letter Z, the YXB. So angle, this angle will be equal to this one. Okay, letter Z to BXY. Okay. Okay, please look at these two angles very well. We have proved that this angle equal to this angle and the angle of tangency equal ACB. So of course BAY will be equal ACY. What is this one? What is the relation between these two angles? As you see, this is exterior angle for YXAC, and they are equal. And we know that when the exterior angle equal to the interior angle for the adjacent, so this is a cyclic quadrilateral. Okay, since angle BXY is exterior from the quadrilateral XYCA, so XYCA is a cyclic quadrilateral. Okay, the last part we have here is the converse of theorem 5. We said that theorem 5 says what? Theorem 5 says that the measure of the angle of tangency equal the measure of the inscribed angle suspended by the same arc. Here is the opposite. If you have an angle, the angle of tangency, an angle, okay, from a ray drawn from one end. I don't know that this is a tangent yet. A ray drawn from one end of a chord of a circle, so that the angle between them and this ray, this angle, equal to the chord, this angle and the chord is equal to the measure of the inscribed angle suspended by the chord in the alternate side, then this ray is a tangent. If these two angles are equal, so this is a tangent. A ray drawn, this is only here a ray drawn. Okay? The angle, this angle, the ray with the chord, if it is equal to the inscribed angle, which is opposite to this arc, so this ray is a tangent. So if AB is a chord in circle M, AD is drawn such that measure of angle BAD equal measure of angle C, then AD is a tangent for the circle. In each of the following shapes, show that AD is a tangent. I here want to prove that, or to show that AD is a tangent. Passing through, tangent for what? Where is the circle? Passing through the vertices of the triangle ABC. So if I have got two angles like this one, so it is a tangent. Okay, here ABC, as you see, AC equal to CB, it's isosceles triangle, so this part will be 65, and the whole angle DAC is DAB, sorry, 130, so the small part here will be also 65. If I imagine that there is a circle here, if I imagine a circle passing through the vertices, so the angle of tangency, which is DAC, equals 65. If I suppose that angle DAC, it's not angle of tangency yet, there is an angle which is called DAC equals 65, and it is opposite to an angle here which is 65, opposite to the arc I have drawn. So as this one equal to this angle, so AD is a tangent to the circle passing through the vertices of the triangle. Here I have DAB 75 and I have 65x and 3x. Okay, here this is array. Also, if I imagine that there is a circle here, okay, so if I have proved that this angle equal to this angle, so AD will be a tangent. Can I get angle C and angle B? Yes, because I know that the sum of the angles of the triangle equals 180. So 60 plus 5x plus 3x equal 180. So 60 plus 8x equal 180. 60 will go to the other side, so it will be 8x equal 180 minus 60. 8x equal 120, so x will be 15 degrees. So if I want to get angle C, it will be 5 times 15 equals 75. So since angle DAB equals angle C, so AD is a tangent. Here I have angle A 90, angle DAB 60, and I have AC 3 centimeters, CB 6 centimeters. Here, unfortunately, you have to remember a very important theorem that you studied in grade 8, that in the right angle triangle, if you have a right angle triangle and you have a 30 degree, the side opposite to 30 degree have the length of the hypotenuse. Here is the opposite. I have a 90 degree and I have the hypotenuse 6, and one of the sides is half the hypotenuse. So the opposite side angle, will be 30. So what will be the third angle? 60. So since DAB equal to angle C, so AD is a tangent. The last example here we have today, ABC is a triangle inscribed in the circle. AD is a tangent to the circle at A. X belongs to AB and Y belongs to AC. XY parallel to BC, and I want to prove that AD is a tangent to a circle passing through the points A, X, Y. I want to prove that this is a tangent to this circle. Okay? Okay. I will draw it again here. Suppose that this is a circle. I don't know why this one is. I don't want it here. Uh, so please delete. This is the circle. Suppose that this will be the circle here. Okay. Since first before this one, since uh, since what? Since AD is a tangent, so where is the angle of tangency? DAB is the angle of tangency, right? Yes, DAB. It is equal to which angle? Where is the inscribed angle opposite to the arc? Here is the inscribed angle. So since AD is a tangent, so measure angle DAB equal measure of angle C. So angle 1 here equal angle 2 here. And as you see, I have XY and BC are parallel, where AC is a transversal, then measure of angle 2 equal measure of angle 3 corresponding. So 1 equal to 2 and 3 equal to 2. So angle 1 and angle 3 will be equal. So since angle DAX equal to angle AYX, if I put the circle here again, you can imagine that this is the angle of tangency of it, DAX. It is also the angle of tangency of the circle which I had drawn to AXY, and this is the opposite inscribed angle. So since DAX equal to AYX, which is angle 3, so AD is a tangent to the circle passing through the points AX and Y. This was the last example in our curriculum. Of course, I have a lot of exercises. I did all the drills and the examples and the exercises which come inside the lesson, but of course I didn't do the exercise itself after each lesson. I hope that all this curriculum to be studied at school, and I hoped that I saw you all the previous period of time, but that is life, and it's out of our hands that we didn't meet. So I hope that you are all fine, and I really miss you so much. Please keep your health, and eat healthy food, and try to be at home all the time. So please stay safe, stay home. Thank you, grade 9.